exam, but that's what you conclude. Or similar example, how to read those guys. Y1t, how does it react to its own past shocks one period ago? Phi 1, 1, 1, 1.2. And so on. Okay, as I told you, I'm aware that vector autoregressive analysis, there exist thick books and one could teach the whole term on this issue. We just talked about it one afternoon, but at least I want you to know the crucial things, which are, again, we have to determine the lag order, P. You can do this again with information criteria. I didn't talk about that, but there exist multivariate information criteria. They have to be minimized. So if someone shows you, well, I did a VAR analysis and I have those information criteria, that's why I choose the P specification equal to then you know what the person talks about. Then people do an estimation and they say, well, I report the roots of my polynomial, because remember, all least squares, multivariate least squares. You run y, oops, where am I? Here. You regress yt on yt minus 1. You get estimates of the phis. You can numerically evaluate the roots. And Gretel tells you, well, they are larger than 1 in absolute value. So all roots are larger than 1 in absolute value. I have covariant stationarity. You know what the person means. And then they say, I made an identifying assumption. If they don't say what they do, they typically do what we did, because this is the default, this Cholesky decomposition, which has the following interpretation. This recursive structure. And under this assumption, we come up with impulse responses, and that's how we interpret them. In terms of orthogonal shocks, as people call those U's, uncorrelated. So it's really the direct effect, a shock of the, I don't know, second variable, of the second, shock of the second variable, that's the U2, h periods ago on the first variable, and so on. Yeah, that's the kind of analysis carried out with such vector autoregressions. Or alternatively, people, as I told you, may nowadays do this local projection, but I'm not teaching this yet. I'm just telling you that there is something new which is around. Sorry for all those technicalities. I know what I just summarized in words is not so hard to understand. Of course, all the matrix algebra behind kind of hides the key economic issue, which I just summarized. That's what we really want to do, interpret those shocks. But to argue why, for example, you have this recursive structure assumption, I needed to do a little bit of algebra and this triangular decomposition, and yeah, that's at least what I decided to do. Not much time left, but maybe you have a question. Yes?
Just a bit confused because like when you move from the univariate, the AREL model, there's the intention for this one is like we both want to include the temporal change, but then for the VAR you also want to include the feedback, right? But because we run into the problem of identification, so there's a triangle matrix, so in the end the phi 2 is becomes 0. So isn't it maybe like a little
No. No, not exact. The phis, I don't make the restriction on the phis. The phis I estimate unrestrictedly. That's crucial. It's good that you ask this. Here, no restriction on those phis, unrestricted estimation. then no restriction on the phi's, completely everything may depend on anything else, safe residuals, compute covariance matrix. This is where the restriction comes in. That I say the matrix that defines the structural form, the A0, here I impose the restriction that this matrix has this triangular form of the Cholesky decomposition. Estimation unrestricted, here comes the identifying assumption. And people, as I said, could make different identifying assumption. Okay. Yeah, and choosing a different matrix A, you would get different impulse responses, but the way how you interpret them remains unchanged. The only thing that changes, and is your decision, so to speak, is how to pick the A matrix 0. So I was kind of stressing in the beginning, I should have been stressing, reduced form, unique, structural form, not unique. You could pick other matrices A. That's what I discussed when I said you have like 3 parameters from the sigma matrix and you have 4 parameters in the A matrix. So here you make a choice. How the data information is contained in the sigma. Data, compute from the data, and now this is a matrix. In our situation, it just says one variance, another variance, plus a covariance. Those 3 guys I estimate. And now I must choose a 2 by 2 matrix with 4 entries. And this choice determines the structural form. And how I make this choice will, at the end of the day, affect the impulse response. Because different choices of the matrix A, giving the structural form, will result in here they are given, will result in different impulse responses. The phi's I estimate from the data, unique least squares. Here, how I pick my A0. This determines how I get my impact, my response multipliers. And our choice of A, maybe I should have set up more generally. Yeah, I could have chosen any A, and now we make the particular choice that A is triangular. Yeah. Maybe I should have leave open how I choose A until this very point, and then say, well, how do we choose A? And then make only then the restriction. So didactically, maybe it was not ideal. Anyway, I hope the summary helped to say where you make your assumption, where you make restriction, not on the estimation, but on choosing the matrix A0 from the structural form.
In the univariate case, for the impulse response, basically the vector A is just 1, right? And then
Exactly.
you end up with the CK, it's just the sum of the pi, which is the sum of the coefficient of the outer regression.
Exactly. No identification problem in the univariate case. You have one variance and you have one parameter to estimate because there's only one variable. No identification problem. All right. Thanks for your patience. See you tomorrow. Goodbye.
Không biết tôi ngồi xuống. Không biết tắt anh chưa tắt đâu, chưa tắt đâu. Tắt làm sao?